Day 38, Honors Physics, Example 13. Here's a good problem because it gets at some of the conceptual stuff, conceptual ideas involving static friction. The equation, which you can easily write down, that the force of friction is equal to or less than, it's less than or equal to mu F sub n. That's for static friction. And the less than thing is somewhat troubling, at least initially. What it means is this. For example, in part A here, if you have a block just sitting there, well, we have the force of gravity straight down if you're sitting on a flat horizontal surface, and the normal force straight up, but nobody's trying to push the block. So right now there is no friction. So the force of friction is 0. This is the entire free body force diagram. Force of friction is 0 here, 0 newtons. Now, part B, same block. Here's the full free body force diagram. You're pushing with 20 newtons now. Let's see if friction actually can keep it there, because friction has a maximum, well, static friction has a maximum. So if I go to the top up here, the maximum force of friction is when we put the equal sign in there. Okay, because friction can be less than its max, but its maximum is when you make this an equal sign, straight up equal sign, equals mu, which is 0.30 times the normal force, which we've rounded off to 100. So the maximum frictional force, static frictional force we can have here is 30 newtons. So in case B, I'm going to circle this. This is not an answer, but it's a key to the answer. If in case B, I push with 20 newtons, friction would only match me. If friction was bigger than 20 newtons, the block would start to accelerate in the direction of the bigger force. But in part B, the force of friction must be 20 newtons. Oops, equals 20 newtons. If I push with 22 newtons, friction will be 22 newtons. It can match me up to a point, up to 30 newtons. So in part C, it says, what is the minimum horizontal force? Well, the minimum horizontal force needed to get the block moving is 30 newtons, or 30.001 newtons. So we'll just say it's 30 newtons. Well, that's the break-even point. That's the point now. Will it move or will it not move, or start to move? In other words, accelerate, and then kinetic friction would take over. But you need a force of 30 newtons or something slightly over 30 newtons to get this block to move. Anything less than that, and friction will match it.